Hey, welcome to VMware Explorer Barcelona Day 3. We are still continuing our coverage. There's been so many announcements, but also there's just so many products. There's projects, customers, partners. There's a lot of great content. John, I think it's going to take us a couple of months to get all of the conversations out to the podcast crew. What do you think?
Yeah, it is, and I've been looking at VCF 9. I'm trying to get some beta bits. I'm also trying to prepare some home lab upgrades, and I'm all excited about all these components things going around. But one thing I'm noticing is RAM is kind of expensive.
It's not cheap.
Yeah, and I'm trying to rebuild my lab at work and at home, and I'm like, what am I gonna have to do to get some RAM around here?
I think it's time for memory tiering, man. I love your segues. They're always so creative. No, but yeah, we're talking memory tiering. We're not doing it alone. Good friend of the show, Dave Morera is back. Dave, welcome.
Thanks, Pete.
And also joining us from the VMware Cloud division is, for the first time, I'm sorry, I don't want to mispronounce your name. It is Arvind. Arvind, welcome to the podcast.
Yes, that's the right pronunciation. Thanks.
Excellent. I try my best. I have a last name where everyone mispronounces, so I'm always like, I want to learn how to pronounce people's names. No, but thanks for joining us today. We're talking about memory tiering. So before we even dive too deep, why don't we just do very high level, what exactly is memory tiering? Because when I think of memory tiering, when I think of tiering, I think of like vSAN and disk groups. But so what exactly is memory tiering?
Basically, memory tiering is an exciting innovation that VMware is bringing. It's basically about using a cheaper secondary tier of memory along with DRAM to reduce the overall TCO for a customer. So today we have a lot of costs occurring in the server BOM, and most of the costs are due to the DRAM. I think I've heard 50-60% of the server BOM costs are from DRAM alone. So this is a way of sort of reducing the overall TCO for our customers, while at the same time improving the resource efficiency, such as the CPU utilization.
Oh, okay.
So from the CPU efficiency, what's driving that? It's I can consolidate to fewer hosts and...
Yeah, so one of the things we have seen over many surveys and from talking to customers is our customers' CPU utilization tends to be pretty low, in the 20-30%. And given that most of the software licenses and whatever you run,
cores,
they are based on cores and CPU, right? So we are trying to optimize on that and bringing this memory tiering so that when customers deploy additional memory, they at the same time get better utilization on the CPU.
We got the why there. This is going to help drive down that cost. Like you said, average cost, half the cost servers RAM. Maybe on the denser nodes, you start doing SAP HANA and weird stuff, it goes to like 70-80%.
Correct.
Memory overcommit is not a new... The whole idea of trying to do different things with memory, it's not a new thing to us. We've done memory compression, we had transparent page sharing, intra and between VM, all that. We've had swapped SSD, ballooning.
Yeah.
What is different from this versus the other traditional memory overcommit technologies VMware has?
Yeah, so with memory tiering, it goes sort of beyond these schemes. I mean, overcommit is a way of sort of providing this notion of creating additional memory, but at the same time, at the end of the day, it depends on the actual physical memory. And what we are giving with memory tiering is actual physical memory, but although it's slower, but it's real memory, right? So customers don't have to actually worry about running into issues with memory.
So byte addressable versus a block, like a swap operation.
And one of the differences here is that you provided a dedicated NVMe device for the tiering purposes. So it happens even before ballooning and all that. So you're expanding the logical memory that a VM can see, right? From that perspective, Pete mentioned vSAN, and that's how I usually explain it to customers so they understand better, right? We have a fast cache or a fast tier at the beginning, right? That's where all the active stuff happens. So the active pages, we go through that portion, that tier, and then you can move down to, hey, whatever pages are not being used or are just cold, then we can move those down and move them up and down as needed. So kind of like vSAN in the early days,
right?
And that resonates a lot with customers. Hey, I get it, it works. Right, and those NVMe devices are, fairly fast.
PCIe Gen 5 is an outrageous amount of bandwidth.
Right. We still have some requirements as far as endurance and performance, obviously, because there's a lot of reads and writes that going on.
If I'm going to that and I'm addressing in a byte addressable complex, that's going to be a lot faster than it was, doing block addressable, which is always a much higher latency and access, and doing that over a 16 gig gigabit per second fiber channel network. Just wildly different size of pipes
Yeah,
here.
but going back to the why, I mean, if you think about, hey, I have all my CPU slots full, and I have all my DIMMs, all my banks are full for those specific CPUs. Now what? What's next? Well, if I don't have memory tiering, my next steps will be to buy a new server, right?
I'm buying sockets to buy DIMMs.
Right, and not buy exactly, and not buy. So that comes with licensing, rack
Yes.
space, power, cooling, right, and all that. Not only that, but now I bought my servers 3 years ago. Now I don't have those CPU available, so now my cluster is gonna be not the same. I'm gonna have generation 4 and generation 5 with a particular CPU. That becomes a problem, right? So if I want to easily scale my memory footprint, that's a super easy, super cheap way to achieve that, and that's one of the features that we serve through vSphere.
So in the scaling, what do you see as driving the scaling? Is this tier 0, cutting edge databases? Is this my tier 2, my stuff I'm just trying to cost optimize? Is this John's home lab? Like which of these 3 use
Yes.
cases?
Yes. Well, Arvind can expand on that, but yeah.
Sure. So generally, what we are seeing is enterprise applications. I mean, as they evolve, they tend to take more memory, right? I mean, they tend to become more memory bound rather than disk bound, right? Rather than storage bound. So what we are seeing is a general growth in the enterprise applications, and those applications are moving more and more into memory, like be it cache or whatever. And we see this across the board, even with traditional databases like SQL, Oracle, right? So they are all using more and more memory. They want to cache more because they want to give better experience from an application point of view.
Yeah, an interesting use case would be, I've been hearing a lot from customers this week, and they're like, well, I want to deploy VCF, right? But it's asking me for a lot of resources. No, I think memory tiering would be a great use case.
Yeah.
So you got to work on that, Arvind, right? To provide some additional resources so we can have a home lab. Customers can use it and play with it with VCF.
So I can download a terabyte of RAM SSD, put it in my NUC, and
get
run
an
holodeck, run my nested VCF.
M.2 NVMe and go crazy on it.
So, obviously, I saw the tech preview for this. It's out on AE3. This is using just PCIe attached NVMe devices. But I've been looking at some server hardware. It looks like there's some kind of different interfaces and things coming. Looking kind of we can't discuss all the roadmap, but where are we seeing hardware go for memory and these devices? What's beyond PCIe?
Basically, VMware has been in this journey since the last, I think, 5-6 years. We have explored multiple technologies, and for us, Optane used to be, one of the big ones, right? And we had a lot of hope and promise from Optane. And we had Project Capitola at some time, right? Which was based on
NVDIMMs and all of that.
Right. So unfortunately, that didn't pan out. I mean, the
hardware was a bit pricey, and the adoption wasn't there. So.
Right. So we moved to exploring other alternatives, and NVMe stood out as one of the easiest, most adoptable commodity-based.
Every server has it.
Every server has it, literally, right? And now we are also looking into how do we make it more performant, right? So one of the things is not only do we care about capacity, but we also want to make sure that applications don't suffer from any performance, right? And then we also want to make sure that we take care of the latencies associated with these devices.
So with NVMe, storage sitting on a stick, so to speak, my memory controller is going to have to go back and forth and talk down that. Like,
exactly.
What could be done, I guess, to handle that latency leg?
Yeah, so we are introducing memory controller-like functions into the device. There's a new technology called CXL.
I see that some of the PCIe bays are marked as that on the new servers.
Right. So with that, actually, we have a memory controller-like functions coming into the device. And what we are doing with Project Peaberry is bringing more capabilities, reducing some of the performance and latency concerns, and also reducing the application jitter. Because one of the things, if you see, is customers who run sort of some of these latency sensitive applications, interactive applications, you see a lot of jitter, right? And CXL, the type of protocols we use, can help reduce that.
So this is cool. I've got GPUs, I've got DPUs. Like, servers used to be boring. It used to be CPU, RAM, NIC, maybe a
hardware's
channel
coming back,
HBM.
man. I'm telling you. Yeah.
Hardware's coming back, absolutely.
We've got CXL, we've got special external memory controller-y things.
Yeah.
Like, We're all gonna have to become hardware nerds again. This is fun.
We're gonna end up buying building our own servers again, our own home computers again, right?
Yeah,
From
absolutely.
scratch,
John's
right?
home lab, man, I feel bad for his wife. It's going to just keep getting bigger and bigger. But thanks to memory tiering, at least it'll be a lot cheaper. So
There we go.
Yeah.
Gentlemen, thank you so much for joining us on Virtually Speaking
Of
this
course.
week, and enjoy the
Thank
rest
you.
of your week.
Thank
Thanks,
you.
Pete.
Thank you.